In the deepest, most unsettling corners of theoretical physics, a chilling secret whispers through the equations, challenging the very fabric of existence. For millennia, humanity has dreamt of a universe infinitely divisible, a smooth, unbroken canvas stretching into the void. But what if that dream is a lie? What if, at its most fundamental level, reality isn't continuous at all but pixelated? Like a cosmic image with a built-in resolution limit, imagine zooming in on the universe, past galaxies, past stars, past atoms, past quarks, only to hit an invisible wall, a boundary beyond which information simply cannot exist. Scientists have uncovered a terrifying truth, an absolute speed limit, not for light, but for the very data that makes up our reality. It's called the Bekenstein Bound, and it screams that our universe has a maximum information density, a point beyond which reality simply cannot get any sharper. It's the ultimate digital frontier. This isn't just abstract math. It shatters our perception of reality, hinting that everything we experience, every star, every galaxy, every thought, might be rendered on a finite, pixelated screen. What if our entire universe is nothing more than a cosmic hologram, projected from a boundary we can never see? A grand illusion with a terrifyingly low pixel count. You think black holes are just cosmic monsters, right? Devouring stars, crushing galaxies, screaming, nothing escapes. But they guard a secret so profound, it redefines reality, whispering truths that shatter our most fundamental assumptions about existence. For decades, we believed anything falling past their event horizon was gone forever. Information, the very blueprint of existence, obliterated. Stephen Hawking himself championed this, declaring black holes cosmic incinerators, erasing data from the universe, a terrifying thought, violating the sacred laws of quantum mechanics, which insist information can never truly be destroyed. Then, a brilliant, audacious mind stepped forward, Jacob Bekenstein. He looked at these ravenous beasts and saw not destruction, but the universe's ultimate filing cabinet. He posited a radical idea, a cosmic heresy. Black holes don't destroy information, they store it, not within their crushing volume, where matter compacts to infinite density, but on their surface, their event horizon. Think of it like this. You have a colossal library. Common sense screams that its information capacity depends on how many books you cram into its volume, words. But Bekenstein, with a stroke of genius, argued that for a black hole, the capacity is measured by the surface area of its event horizon. Every single square Planck unit, the smallest conceivable unit of space, on that shimmering, inescapable surface, could hold one solitary bit of information. It was like a cosmic hard drive where the data wasn't inside the disk, but meticulously etched onto its boundary. This was revolutionary. It meant black holes weren't cosmic shredders. They were cosmic registrars. They weren't erasing the universe's data. They were diligently cataloging it on their impenetrable shell. This insight, born from a desperate attempt to reconcile Einstein's gravity with quantum mechanics, became the first undeniable clue in our cosmic detective story. It screamed a terrifying revelation. Information isn't infinite. It's finite, quantist, and terrifyingly, physically limited. The universe, it seemed, had a maximum resolution. Bekenstein's audacious idea wasn't just about black holes. It was about everything. If a black hole's information capacity is fixed by its surface area, then this must be a fundamental property of space itself. He proposed what's now known as the Bekenstein Bound, an absolute, unbreakable limit on the amount of information that can be contained within any finite region of space. This isn't some abstract mathematical curiosity. It's a cosmic speed limit for data, a maximum density of reality that screams at the very fabric of existence. Imagine for a moment that your entire observable universe is a giant, hyper-realistic video game. You zoom in, and the graphics are stunning. The textures incredibly detailed, but even the most cutting-edge game eventually hits its limits. You can't zoom in forever without hitting the fundamental pixels, the smallest units of information the game engine can render. The Bekenstein Bound is the universe's ultimate pixel density. It says there's a point beyond which no more information, no finer detail, no smaller subunit can be crammed into existence. Every particle, every field, every interaction, every single event in the cosmic drama, it all takes up information space. And that space fundamentally is finite. This isn't just theoretical musing. This bound is inextricably linked to the Planck length, the smallest conceivable unit of distance in the universe. We're talking 10 to the power of minus 35 meters. To put that in terrifying perspective, if an atom were the size of the entire observable universe, a Planck length would still be smaller than a single grain of sand. This isn't just a number, it's physics' ultimate pixel, the bedrock of reality. Below this scale, our familiar notions of smooth, continuous space and time simply shatter. Reality becomes a churning, frothing quantum foam, a shimmering, indescribable chaos where even the very concept of where and when loses meaning. And hand in hand with Planck length comes Planck time, the smallest possible unit of time. This means not only is space pixelated, but time itself ticks forward in discrete, unimaginably tiny increments. No continuous flow, just a cosmic clock clicking at its most fundamental, irreducible rate, a cosmic heartbeat that defines the very pulse of existence. If the Bekenstein Bound dictates a maximum information density, and the Planck length and Planck time define the smallest possible pixels of space and time, then the terrifying, mind-shattering conclusion is inescapable. Our reality is not infinitely smooth. It is pixelated, discrete, fundamentally digital, like a vast cosmic image rendered with a finite number of information bits, or a game running at its highest possible resolution, yet still ultimately composed of individual data points. We don't perceive these cosmic pixels because we are inside the picture, made of the very pixels themselves. Every star, every planet, every living cell, every thought you've ever had is composed of these fundamental information units, meticulously arranged into the intricate dance we call reality. This isn't just a limit on what we can observe, it's a limit on what can be. It screams that our universe is fundamentally digital, a cosmic tapestry woven from finite threads of information. It hints at a reality less like a continuous ocean and more like a vast, intricate computer program, a program running on hardware so alien, so fundamental, we're only just beginning to grasp its nature. It implies a universe that, at its deepest level, computes itself into existence, meticulously calculating every interaction, every event, within the ironclad constraints of the Bekenstein Bound. This boundary suggests that the universe isn't just a collection of particles, it's an information system, processing data at the most extreme limits imaginable, a cosmic brain performing calculations on a scale that dwarfs all human comprehension. If this revelation has shattered your assumptions about reality, and you're hungry for more cosmic secrets, smash that like button. And for regular journeys into the mind-bending depths of the universe, make sure you subscribe and join our crew of cosmic strategists. You won't want to miss what we uncover next. If reality is pixelated, a cosmic image rendered with finite information, then the next logical question screams at us from the void. How? How can three dimensions, seemingly solid and vast, emerge from something fundamentally discrete? The answer, a concept so mind-bending, it will twist your brain into a Mobius strip, is called the holographic principle. Imagine a simple credit card hologram. It's a flat two-dimensional surface, yet it encodes all the information needed to project a vivid three-dimensional image. You tilt it, and the image shifts, reveals new perspectives, depth and texture. It feels three-dimensional. But the data, the true source of that reality, is fundamentally flat. Now scale that up, way, way up. The holographic principle proposes that all the information contained within any volume of space, every star, every galaxy, every atom, every thought, can actually be encoded on its two-dimensional boundary. It means our entire 3D universe, with all its unfathomable depth and complexity, might be nothing more than a colossal cosmic hologram, a shimmering illusion projected from an unimaginably distant, two-dimensional surface we can never truly perceive. This isn't science fiction. It's a terrifyingly elegant solution to the Bekenstein Bound. If information in a black hole scales with its surface area, then the universe itself, at its most fundamental level, might be operating on the same principle. The immense volume we experience is just a sophisticated projection, a cosmic movie playing out on an unfathomable screen. Our perceived three dimensions are merely an emergent property, a trick of the light and the intricate dance of information encoded on a distant, flat boundary. Think of it like this: your entire reality, the chair you're sitting on, the air you breathe, the beating of your heart, could be a phenomenal, hyper-realistic special effect, a dazzling display rendered from a flat data source. This shatters the very notion of what real means. Is the universe genuinely three-dimensional, or are we living inside a cosmic projection meticulously crafted from the ultimate pixelated canvas? The clues are piling up, leading us down a rabbit hole where the distinction between reality and illusion blurs beyond recognition. This is the next piece of the puzzle, revealing that the universe isn't just pixelated. It's a masterpiece of cosmic trickery, a grand illusion playing out on an invisible stage. If our reality is pixelated, limited by the Bekenstein Bound, and projected holographically from a two-dimensional boundary, then the final, most audacious question screams from the abyss of possibility. Is our universe a simulation? The veil between fundamental physics and simulated reality thins to nothing. Consider the sheer computational power needed to simulate a universe. Every particle interaction, every quantum fluctuation, every cosmic ray, every thought in every brain across billions of galaxies. It seems an impossible task, even for a supercomputer of infinite capacity. But here's where the Bekenstein Bound and the holographic principle converge to offer a terrifying answer. If all the information for our 3D reality is encoded on a 2D surface, then the computational load scales not with the vast volume of space, but with the surface area of its boundary. This radically reduces the processing requirements. It transforms an impossible calculation into a merely mind-boggling one. Our cosmic event horizon, the ultimate boundary, could be functioning as a colossal, hyper-advanced cosmic computer. Every pixel of reality, every fundamental unit of information would be a computation. What we perceive as the laws of physics, gravity, electromagnetism, the strong and weak nuclear forces, could simply be the algorithms, the code, running this universe-sized program. The elegant mathematical precision that underpins our cosmos wouldn't just be a tool for understanding reality, it would be reality, the very language of the cosmic operating system. This isn't just a philosophical thought experiment, it's a terrifyingly plausible outcome of the most cutting-edge physics. If reality is information, and information is limited and projected, then the line between real and simulated dissolves. We are the data, the consciousness that emerges from the complex processing of cosmic information. Our thoughts, our choices, our very sense of being, are they genuine expressions of free will or the inevitable outcomes of incredibly sophisticated calculations performed by a cosmic supercomputer? From our internal perspective, it makes no difference. We experience consciousness, love, pain, wonder entirely authentically. The simulation is so perfect, so utterly immersive, that it is our reality, and the implications spiral outwards. If our universe is a simulation running within a black hole's holographic boundary, then every black hole within our universe could, in turn, be running its own nested simulation. Galaxies, stars, planets, and potentially conscious beings, all experiencing their reality as completely authentic, never suspecting they are living within a cosmic program, which itself is running within another cosmic program, an infinite recursion of simulated realities, like cosmic matryoshka dolls, each one containing universes within universes. The Fermi paradox, the perplexing silence in our vast universe, suddenly takes on a chilling new dimension. Perhaps advanced civilizations don't colonize the stars because they discover the true nature of their reality. They are already part of a simulation. Their ultimate technological achievement might be not space travel, but understanding and manipulating the code of their own simulated cosmos, or even creating new simulations within their own black holes. We might be living inside the ultimate detective story, where the crime is the illusion itself, and the solution is the terrifying realization that our reality is nothing more than a meticulously crafted, pixelated, holographic, and utterly convincing cosmic program. The universe, it seems, is the ultimate computer, and we are its most complex self-aware output. So here we stand, at the edge of everything, staring into the abyss of a pixelated, holographic, possibly simulated cosmos. The Bekenstein Bound, once an obscure limit for black holes, has become a cosmic mirror reflecting a chilling truth about our own reality. Jacob Bekenstein, the audacious mind who dared to quantify the information of a black hole, unwittingly handed us the first clue to a universe that might be fundamentally digital, a grand illusion played out on a two-dimensional stage. This isn't about proving we live in a simulation with 100% certainty. It's about the search, the relentless human drive to peel back the layers of reality, no matter how unsettling the revelations. It's about the thrill of a cosmic detective story where the greatest mystery is our own existence. If the universe has a maximum resolution, if it projects our 3D reality from a 2D boundary, then the very nature of consciousness, free will, and what it means to be becomes the ultimate frontier. Are we conscious beings experiencing an authentic, infinitely detailed cosmos? Or are we the incredibly complex, self-aware output of a cosmic computer, dancing to algorithms we call the laws of physics? The answer remains tantalizingly beyond our grasp, but the questions themselves are a testament to the universe's greatest creation, a mind capable of contemplating its own cosmic circumstances. The search continues, driven by an insatiable curiosity that defies the boundaries of any perceived prison. Tell me what you liked or disliked about this video. What do you think could be changed to make it better? I read every comment and will respond to every suggestion.